Hello, everybody. Welcome to the notes on sequences. We're going to go ahead and start off with what a sequence is and the different parts of it, and then we're going to get into two different types of sequences that are going to be useful today. So a sequence is just a set of numbers that are in a particular order or in a pattern, and they can be finite or infinite. Finite meaning that the sequence stops at a number, and infinite meaning that it goes on forever. So I've got an example of each. Example 1 is the finite example because we stop at the 15. And example 2 would be an infinite example because it stops at 4, but then notice we have the 3 dots. That means it's going to continue on in that pattern. Each individual item here is called a term. So this would be the first term, second term, third, fourth, fifth, and so on. And obviously these can have infinitely many terms if they go on forever. Okay, so that's the general definition of a sequence, and now we're going to talk about two types of sequences. The first one is called the arithmetic sequence, and this is a sequence found when you add a constant value each time, and that value that you're adding each time is called the common difference. So all you have to do to find the common difference is figure out what number is being added each time, and then you'd be done. An example here says determine if the sequence is arithmetic. So the way to check this is to see if the number that is added each time is the same. And we've got these four numbers listed here: 5, -6, -17, -28. So if I check how to get from one number to the other, in this case from 5 to -6, we subtracted 11. To go from -6 to -17, we subtract 11. And then to go from -17 to -28, we also subtract 11. So because the same number is being added or subtracted each time, that means it is arithmetic. And then the common difference would be -11 if it asked. Okay? So pretty basic. Just check and see if the number is the same each time, and then you could say yes or no. In this example, it says consider the sequence 18, 14, 10, and then notice it's got the dots, which means it continues. So it says in part A, find the next four terms of the sequence. Before you can find the next four terms, you have to know what the common difference is. So how did we go from 18 to 14 and from 14 to 10? Well, we subtracted 4 each time. So to go to the next sequence, I'd subtract 4. So 10 minus 4 is going to get you 6. And then 6 minus 4 would get you 2. And then 2 minus 4 would get you -2. And then lastly, -2 minus 4 would get you -6. So notice I've just subtracted the same number every time to get the next four terms. Part B of this problem asks you to graph those first 7 terms. In order to graph them, you have to think of them like ordered pairs. So what I've gone ahead and done here is thought of each of these terms as an X and a Y. So the 18 is our first term, so I would graph it as 118. The 14 was the second term, so I graphed it as 214, and so forth. The 10 would be the third term, so 310, and then 6 would have been the fourth term, so 4, 6, and then I continued on to plot them here. And what you should notice is that those terms in our sequence create what looks like a line, and that's a common theme for the arithmetic sequences. So when you graph them, they should form a straight line. Now the next sequence we're going to talk about is the geometric sequence, and those are similar to our arithmetic sequences, except these are going to be multiplication problems instead of addition problems. So to find a geometric sequence, you're going to find what you multiply each time, and that is called the common ratio. Instead of common difference, common ratio. And in this example here, we've got these four numbers. We could go ahead and figure out how to get from -2 to +6. That would be by multiplying by -3. Then same thing, 6 times -3 is -18, and then -18 times -3 is +54. So our common ratio would be -3, and it would be a geometric sequence. Now in this example below, same concept. It says find the next 3 terms of the sequence. So you have to figure out what it is you're multiplying by each time. Now, with a geometric sequence, you could be multiplying by a whole number or a fraction, depending on if you're getting larger or smaller. So in this case, we're getting smaller each time, which means we're going to be multiplying by some fraction. So to get from 32 to 8, we're dividing by 4. That's the same as multiplying by 1/4. So I'm going to multiply by 1/4 here. Same thing. 8 times 1/4 gets us 2. So to find the next 3, I'm going to take 2 times 1/4. That's 1/2. Then take that answer, 1/2 times 1/4. That gets us 1/8. And then lastly, take 1/8 times 1/4, and that gets you 1/32. So here are the next 3 terms in order, and then you'd be done. So geometric sequence is multiplication, arithmetic sequence is addition. That's pretty much it. Okay. The only other thing I'd like you to look at is the differences in their graphs. Notice that the green dots represent the arithmetic sequence, where they increase by the same amount each time. And then the geometric sequence, because we're doing multiplication, is going to get exponentially larger or smaller, which means it's going to have an exponential curve to it. And so that's why it's not in a straight line, because it's going to start growing quicker or decreasing quicker. So it's important to be able to identify the differences in the way we find our numbers, as well as the differences in the graphs of those numbers.